This is a presentation on behalf of RockFuel Innovations. RockFuel is a corporate identity which we employ to promote our inventions and innovations. The slide here reveals part of Western Europe from space. London and Paris can be seen as the two major clusters of light. The countries of Europe are not going back to being agricultural economies. Europe and the world are addicted to energy, and we can't just turn the lights out. However, greenhouse gases have risen at such an alarming rate since global industrialisation, and these levels are rising at such a rate largely due to the use of fossil fuels. It is a fact that the result is global warming. A recent Horizon programme by the BBC, investigating the possible dangers that may lead to the extinction of mankind, stated that scientists believe that this is the biggest single threat. There are now solutions for electricity production by use of renewable and nuclear energy. But power for transport is still largely limited to fossil fuel, and here we have the real problem. To meet our legally binding carbon targets, we need a commercial carbon-neutral solution for transport. Our invention is a significant solution on a worldwide scale. Using our patented process, countries such as the UK effectively have as much oil as Saudi Arabia. What is more, the resources that we need to make our carbon-neutral petrol are plentiful, cheap, politically secure, and are environmentally safe. It has been said that there is nothing new under the sun. This is a good example. The process that we have invented does not have any new risky technology. Part is ancient and part is modern, but each of the steps are proven. The process is unique and has therefore been awarded a full United Kingdom patent and has international patent pending. So let's walk through the novel sequence of steps that come together to make this unique proven solution for carbon-neutral fuel. Our process starts with limestone, one of the most common rock types on the planet. This is placed into our patented rotary lime kiln. The process of heating limestone has been happening for centuries. The only difference with our process is that the heat source comes from superheated steam produced by a nuclear plant. This steam would typically be produced while the nuclear plant has spare capacity, such as night time and other off-peak times when electricity generation is at a minimum. Once heated, the limestone produces two key elements, quicklime and carbon dioxide. Both of these are important to our process, and it is here that our story splits into two. Keeping in mind the carbon dioxide side of the story. As a parallel process, using the same off-peak steam as our heat source, we produce hydrogen by way of high-temperature electrolysis, or the sulfur iodine process. Using the Sabatier process, carbon dioxide and hydrogen are combined to produce synthetic fuel in the form of methane, methanol and butane. Further processing allows for the production of synthetic diesel and petrol. Again, each of these processes are well established and proven. Let's return to the quicklime side of the story. Quicklime is like a sponge. Having had its carbon dioxide removed, it immediately starts collecting and retaining more carbon dioxide as it starts its return to limestone. This process can be accelerated by placing quicklime in places of high temperature, such as factories or fossil fuel power stations, or places of high carbon dioxide concentration, such as roadsides, tunnels and within vehicle exhausts, or even within seawater, where carbon dioxide is collected from the sea itself. This quicklime can be seen as a rechargeable battery, which once recharged, can be returned to the lime kiln to have its carbon dioxide removed once again. This cycle can be repeated over and over again. And when considered as a whole, you can see how the process becomes carbon neutral, as the same amount of carbon is collected and recycled as is emitted by the burning of the finished fuel. This is the overview of the RockFuel process to produce carbon neutral fuel for existing combustion engines. The heart of our innovation and patent is the nuclear-powered lime kiln. Lime kiln technology has been proven over hundreds of years, but the problem with conventional lime kilns is that they rely on combustion of fossil fuels for their heat source. The traditional lime burning process produces significant greenhouse gas pollution. Limestone is calcined in the lime kiln, but it is not necessary to have combustion to calcinate limestone. It is sufficient to heat the limestone to an optimum temperature of 850 to 900 degrees Celsius, and this is achieved by our process. The source of that heat is nuclear power, which is accepted by any objective criteria as being carbon neutral. Our lime kiln produces approximately 6 parts quicklime to 4 parts carbon dioxide in a carbon neutral manner, and both the quicklime and the carbon dioxide are important components for our unique process. The best nuclear plants for this process are already in operation in China, modular helium-cooled reactors. Much of the world's existing nuclear infrastructure relies heavily on pressurized water reactors. We do have a solution for this infrastructure, but it will be less efficient. However, even there we can still utilize cheaper off-peak steam for a significant part of the heat needed for the process. Furthermore, waste steam, both peak and off-peak, can be recycled with the quicklime in situ at the plant to absorb carbon dioxide from the atmosphere. Again, we make the point that the application of nuclear power exists. It is proven and ready for an increase in efficiency. We do not need to wait for Generation 4 reactors to be designed for this process. The reactors already exist. Taking the UK as an example, you can see the massive reserves of limestone with which this country is blessed. In terms of oil, by using our process, you are looking at the equivalent of the Middle East. It is not only the UK and Western Europe that has such plentiful reserves. Limestone totals over 7% of all the rock in the world. Hydrogen is seen as a fuel of the future. Experts, even in the oil industry, believe that its cost mile driven is more competitive than gasoline, but it is no match because of the huge problems with hydrogen regarding transport and storage. Using our process, the hydrogen produced in the plant is immediately combined with the carbon dioxide also produced, and then processed further to make a straight petrol-gasoline substitute that does not have these problems. The other problem with hydrogen is that it is usually produced using fossil fuels, which would defeat the object of attempting to have a carbon-neutral vehicle fuel. It has been proved that hydrogen can be produced economically and in a carbon-neutral manner using high-temperature electrolysis, or the sulfur iodine cycle. This is dealt with later in the economics part of the presentation. Both of these processes can be powered by a nuclear facility, which will be in situ at the plant. It may be that the problems with trying to use hydrogen alone as a vehicle fuel will be overcome one day. In the meantime, our solution is available now, ready for consumption by the millions of existing engines and vehicles that need petrol and gasoline. We see China taking the lead in this production process, and they have already built the reactors to make carbon-neutral production of hydrogen in commercial quantities. Coupling our process to this state-of-the-art infrastructure will produce the most efficient solution. Yes, hydrogen is the fuel of the future, but in the meantime, our process enables it to be used by all of the existing engines in the world today. The carbon dioxide and hydrogen are heated under pressure, using the heat and pressure from the plant. The power from the reactor is constant, not intermittent, and is ideal for driving this process. Using the proven Sabatier process, the resulting methane can be processed further, also using the heat and pressure in the plant to make further hydrocarbon fuels such as methanol, butanol and butane. So again, this step in the process is already proven as a commercial reality. As the quicklime reabsorbs the carbon dioxide, it reforms back into limestone which can be recycled. Thus, the process is also sustainable. The use of quicklime in this way opens up a wide range of possibilities by locating carbon dioxide batteries in strategic environments where the most carbon dioxide can be collected. Some examples are listed here. This aspect of the process has endless exciting possibilities. People can get involved in communities, schools, the voluntary sector and with corporate sponsored collectors. Government and local authorities can get involved with infrastructure and the placing of carbon dioxide batteries in such places as sea defences, submerged collectors in seaports, city park art structures and roundabouts. Also, government can get involved with a domestic collection programme and with the implementation of legislation for vehicle exhaust pipe filters. Instead of carbon credits going abroad and therefore being to the detriment of the economy, these are examples of projects for carbon capture within the producing country for its environmental and economic benefit. Organisations would pay to rent these collectors for their eco-credentials. The important difference between this and other attempts at finding a carbon-neutral alternative to petrol is that the cost of this fuel will be competitive to petrol at the pump. Prototypes have been set up by prestigious bodies such as General Atomics USA and the Japan Atomic Energy Authority, evidencing that hydrogen can be produced using carbon-neutral nuclear power as the energy source at $3 per kilo, which equates to the power-to-cost ratio of petrol and gasoline at $3 per gallon. Notably, in the case of high-temperature electrolysis, or the sulfur iodine process, the evidence is that hydrogen can be produced by nuclear power at well under $3 per kilo. There is evidence collected over many centuries showing that the calcination of limestone is a profitable business. Taking into account that the biggest cost of calcination is the heat source, but that has already been taken into account in the figure for production of hydrogen, and the same heat source is used for the bespoke nuclear lime kiln, then it can be seen that the profit must be greater in our process. The size of that profit will vary depending on the batch of limestone to be calcinated at any one time. It is accepted that calcination on this scale will increase the supply of quicklime and therefore reduce its market value. Against this, quicklime will be in greater demand because of its carbon dioxide absorption properties in the context of carbon credits available because of climate change legislation, which will act to increase its value. The Sabatier process and onward refining will make use of the heat and pressure that already exists in the plant, thereby minimising the cost of this step in the process. Even a BP executive has said that hydrogen is more competitive than gasoline in terms of cost mile driven. Our process has now overcome the problems of storage and transportation that he used as the argument against hydrogen. Furthermore, because there will be a profit in the quicklime and carbon dioxide production half of our process, then the most that our product will cost will be approximately the cost of the hydrogen produced, and is likely to be less than that cost. Thus, we have a product that is potentially more competitive than petrol and gasoline at the pumps. In addition, the following can be taken into account. The fact that the government of the country producing this fuel need not tax this product to the extent that it has to be in the case of refined crude oil, because of the huge balance of payments benefit for that country in making its own petrol rather than importing. The fact that a vast number of jobs will be created in that country for such an industry. The fact that the country will avoid international carbon taxation as a result of legally binding international treaties, such as the Kyoto Protocol. In conclusion, it can be seen that the economic advantage for a country making its own petrol and gasoline using our process, rather than importing oil, will be spectacular. Other than the economic advantages, the broad benefits of our unique solution are summarised here. The product can be produced by a wide range of nations. The only requirement is a nuclear facility. Consumption is in the same country as origin. This means less shipping and transport costs and less carbon dioxide emissions. It is an inexpensive and safe production process. There is nothing new. Many aspects have been successful for hundreds of years. There will be an easy adoption for production and consumption, simply because we are addicted to fuel. Just think of how many combustion engines that we have in the world. This is a sustainable solution. The more fuel that we produce, the more carbon dioxide we take out of the environment. Carbon neutral leadership. Which nation would not want to be the first carbon neutral country? There is a considerable benefit for meeting carbon targets. That is by keeping your existing vehicle and transport infrastructure, but without the international penalties. Enormous political benefits. Implementation of our process will insulate any country from the devastating effects of oil price fluctuations, which will give them independence from major oil-producing countries that are prepared to curtail production of crude oil for their own political ends. The world needs carbon-neutral power for transportation now. We do not need expensive new research and technology. There is nothing new under the sun, and this is the solution.